In today's lesson, we'll be learning how to use similar triangles to solve problems. As you can see, we have a triangle ABC and triangle PQR. We know that they are similar because of this symbol. This is called a tilde or just a squiggle. Previously, we learned that in similar triangles, corresponding angles are equal. We also learned that the ratio of corresponding sides are equal. And you can see that represented mathematically right here. Since these ratios are all equal, we can simplify that and represent it by a constant. The constant is k, and it is called a scale factor. As you can imagine, this scale factor basically tells you how much bigger one triangle is to the other or how much smaller it is. Over on the right, if you take the ratio of the area of the similar triangles, that will be equal to the scale factor squared. So these are the areas I'm talking about, and this is the scale factor which has been squared. That's a relationship between the areas of these two similar triangles. In our first example, we know that the triangles in each pair are similar. We want to find the unknown side lengths. How do you know these two triangles are similar? Well, if you take a look at the diagram, you can see that corresponding angles are equal. Now, if the two triangles are similar, that also means that the ratio of corresponding sides are equal. So let's represent that mathematically. So I'm going to write AB over side DE. That should be equal to the ratio of side AC over side DF. And that should also be equal to the ratio of sides BC over side EF. And again, you'll notice that I'm keeping my ratios consistent. So the smaller triangle is all in the numerator and the larger triangle is all in the denominator. Once you have this set up, all you need to do is just substitute in your values. We know the length of AB is 4. DE is the variable f. AC is 6. DF is 12. BC is 7. And EF is D. Let's first try to figure out the value of f. So I'm going to be using this ratio as well as that ratio. Okay, so let's do the work down here. I'm going to rewrite 4 over f equals 6 over 12. Now, different people might want to solve this in different ways. I'm going to do this method where I'm going to cross multiply. So that is 4 multiplied by 12 is equal to f multiplied by 6. That simplifies to 48 equals 6f. You can divide both sides by 6 to get rid of the 6. The 6's cancel out, and all you're left with is 48 divided by 6. And I'm just going to flip this around so I'm reading it from left to right, and 48 divided by 6 is 8. We're going to do the exact same thing when figuring out D. So let's rewrite that ratio. Instead, we're going to be using this ratio and that ratio. So that's right, 6 over 12 is equal to 7 over D. Again, you can solve this in any way that you wish. I'm going to cross multiply. So that leaves me 6 multiplied by D equals 12 multiplied by 7. Let's simplify this. That's going to become 6D. 12 times 7 is 84. Let's get rid of the 6, and we do that by dividing both sides by 6. The 6's cancel out, and all you're left with is D, and 84 divided by 6, which is 14. Therefore, we've just figured out the values of f and d, and that is 8 centimeters and 14 centimeters. You can write a concluding sentence as well if you like. And moreover, if you really wanted to, you could double check your work by substituting in your values of f and d and seeing if the ratio of corresponding sides are all equal, and they should be. In our second example, we are told that the triangles in each pair are similar. We want to find the area of triangle PQR. How do we know that these two triangles are similar? Well, if you take a look at the corresponding angles, they are equal. And since these triangles are similar, that also means that the ratio of corresponding sides are equal. However, those two things aren't that important right now because we want to figure out the area of triangle PQR. If you recall, there is a relationship between the areas of both triangles, and that involves a constant called k. And we are going to have to figure out that k value, which is also known as the scale factor. So let's set up our ratios. So we only know PQ and ST. So I'm going to set up a ratio PQ over ST, and that's going to be equal to our k value, our scale factor. At this point, all you need to do is substitute in your values. So I'm going to put in 12 as PQ and ST is 9. That is going to be equal to K. You can always reduce this fraction, and that is going to reduce to 4 over 3. I want you to notice that I've put the larger triangle sides in the numerator and the smaller triangle sides in the denominator. We're going to try and keep this consistent when we are looking at the areas of these two triangles. So let's represent this mathematically. The area of triangle PQR over the area of triangle STU is equal to the scale factor squared. At this point, you should substitute in your known values. So we do not know the area of triangle PQR because that is what we're trying to figure out. We know the area of triangle STU, and that is 72 square centimeters. And we already know the scale factor is 4 over 3, and that is going to be squared. If you want, you can change this to a decimal. So let's continue this on. The area of triangle PQR is equal to 4 over 3 squared multiplied by 72. So what I did there was I multiplied both sides by 72. So the 72 on the left side actually cancels out. So the area of triangle PQR is equal to 4 over 3 squared. Now, if I change that to a decimal, that becomes 1.33. I'm going to square that 1.33, and you should get approximately 1.77. I'm only going to carry 2 decimal places here. So let's simplify that. So the area of triangle PQR is 1.77 multiplied by 72, which is equal to approximately 127.44 square centimeters. And that should make logical sense because triangle PQR is bigger than the other triangle. So if you got an area that was smaller, that should be a little bit concerning. That probably means you made a mistake somewhere. So as you can see, that is how you relate the areas of two similar triangles.